So let's proceed to arc length and the area of surface of revolution. We're going to be discussing two topics for this session. So probably it's just easy because once you understood arc length, so the way to solve your surface of revolution is just by rotating the arc length in your 360 degrees with a certain axis of rotation. So it's the same concept as the volume, but what we are rotating right now is just the arc length to create a surface area. So the volume was generated by rotating the area, but this time we're going to rotate the arc length for us to generate a surface area. I think that's what is new here in this topic. So let's go straight to the formula. So the formula is this one. So the length, if you're going to analyze it in terms of dx, you're going to integrate with respect to dx. So this will be the formula on the left side. And if you're going to integrate using the y variable, so this will be the formula. So the formula was derived using the concept of Pythagorean Theorem. So for example, we're going to break the arc length into many line segments. So let's say P1 to P0 to P1, P1 to P2, so on and so forth. So those will be the line segments that will be generated in the curve. So if you try to analyze one line segment, so this will become your differential segment. So that's why, as you can see on the right figure, it's ds. And then let's say this one is from point 1 to the second point of your line segment, of your differential line segment. So with this line, we can create a right triangle. So the x portion will be your differential x value, and the y portion will be your differential y. So you have a right triangle. So notice that if you're going to determine this particular length, so you'll be needing to use Pythagorean theorem. So ds squared is equal to dx squared plus dy squared, or your ds is equal to the square root of dx squared plus dy squared. So notice that the formula is more likely looking at the formulas given. So with a little manipulation, so you may have these equations here. So in terms of x, and the other one is in terms of y. So again, let's not go deep into the derivation, but basta what you understand here is the formula was coming from the Pythagorean theorem, was derived using the Pythagorean theorem. So from this portion here, so there are still a lot of process to do for you to be able to get to the formula. So after Ana, so you'll be able to reach your final format of the equation. So again, you're going to have two formulas. So one is integrating with respect to x, then the other one is integrating with respect to y. So both will give you the same answer, but again, the variable of integration are just different. All right. So let's try to solve the arc length first. So determine the length of y equals the ln of secant x between 0 to pi over 4. So let's say this one is 0 and then this one is going to pi over 4. So notice that in the given example, you are given the limits of x. So meaning you're going to use the format of the formula with respect to x. So the arc length is equal to the integral of, so that will be from x1 to x2, and then square root of 1 plus, so that will be dy over dx squared, and then the dx will be outside of the equation. So that will be our formula. So how do you use the formula is we're going to evaluate this first. So let me try to change color. So you're going to evaluate this one first. So meaning you're going to have dy over dx. So what does that mean is that you're going to get the derivative of this formula with respect to x. So dy over dx, that will be the derivative of ln secant x. So how do you derive ln secant x? So let's try to determine first. So how do you derive ln secant x? So again, as per calculus 1 knowledge or information, or what you have learned in calculus 1, is that this will be du over u. Sakto ba? So if this is u, we're going to get the derivative of secant x. So this becomes secant x tangent x all over secant x. So cancel secant x, cancel secant x. So meaning your dy over dx is just equal to tangent x. Alright, so since this one is squared, so once we go back to the equation, so this becomes from 0 to pi over 4, then the square root of 1 plus tangent squared x. So again, this becomes squared because we have a squared exponent here, and then dx. So take note that this term here is a Pythagorean identity, which will be equal to secant squared x. So this will be square root of secant squared x dx. And then further simplifying is you're going to get the integral from 0 to pi over 4 secant x dx. And again, you can use your calculator. So piligyan at this point, you can use the calculator here, but muna, I just want to make things simpler for the calculator lang para mas dali siya makuha. So the arc length is equal to 0.88 units. So again, it's units because we are measuring distance, length. Okay, so do you have questions so far? Okay, so I think there's no question. So this will be the solution. So notice that from y plus, so from the given equation, so we're going to get first the dy over dx, or we're going to try to differentiate it first, and then getting the square of dy over dx, and then using the formula afterwards. Then you're going to have the answer. All right, so let's move on to another example. So this time is we're going to be having our limits in the y direction. So again, from the formula in terms of y, so this will be from y1 to y2, square root of 1 plus, so this time this will be dx over dy squared, and then dy. So the given length is x equals 2/3 of y minus 1 to the power of 3/2. So we're going to differentiate this one. So this becomes dx over dy. So this becomes 2/3 times 3/2 times y minus 1, right? And then 3/2 minus 1 is equal to 1/2. So dx over dy is equal to the square root of y minus 1. So again, this is just simple differentiation. So exponential rule. So bring down the exponent. So 2/3 times 3/2, and then minus 1 and minus 1. So this will be 3/2 minus 1. That will be 1/2. And then getting the derivative inside the parenthesis is just equal to 1. So let's try to put 1 here. So meaning your dx over dy squared is equal to y minus 1. So meaning if you're going to plug in the values in the formula, so this one is from 1 to 4, then you're going to have square root of 1 plus y minus 1 dy. So again, try to help your calculator so you can cancel out the ones. So you're going to have square root of y dy. Then you're going to get the arc length. So this will be 14 over 3 units, or approximately equal to 4 4.6 ba? So 4.67 units. Okay, so if you're not comfortable with using the y version of the formula, so you can always use the x format of the equation. But take note that since you are given the the limit of integration in terms of y. So you still need to look for the boundaries between the line or the arc length in terms of the x range. So muna siya ang inyong i-kuhan sa. So just try to plug in 1 and just try to plug in 4 to get the equivalent range in terms of the x value. So I think you are just determining the points of intersection, but since you are given the y first, so you still need to determine the x range if you're going to use the x format of the formula. So bali akong pasabot is if I'm going to plug in 1 here, so the limit of in the x range, so if I'm going to plug in 2/3, then 1 minus 1, so that will be 0, 10 to the power of 3/2. So 0 raised to 3/2 is still 0. So the first range is 0. Then I'm going to have 4 minus 1, so 3 to the power of 3/2, and then times 2/3. So the second range is 3 point something, 3.46. And then if you have this range, so you can use the x format of the equation. So this will be your range from x1 to x2. So dy over dx squared, and then you're going to have dx. So I think the problem here now is you're going to convert everything in terms of y. So y equals something, and then you're going to get dy over dx. So I think that's the hassle if you want to use the other formula. So you still need to do some conversions. All right. So this will be the solution. Okay, so since we now understood the concept behind the arc length, so let's try to rotate your arc length in a certain axis, 360 degrees, so that it will be the given arc length will now be converted into a surface area. Okay. So for the formula, is that you're just going to use the same formula for the arc length, but ang napunuan is you're just going to add some equations or add 2 pi r. Because for example, this is the arc length that you're going to rotate about x-axis. So of course the rotating arm will be a semicircle. I mean a circumference of a circle. So the rotating arm will create a circle, and what you're going to generate is the circumference of the circle. So that's why it's 2 pi r, 2 pi times the radius. Right, so if you can see on the right figure, so going towards this portion here, that will be the radius, and then rotating 360 degrees, so times 2 pi. So that's why I think you're just going to solve for the circumference of the circle. Excuse me. Okay, so 2 pi y, and then times the format of the equation. So that will be rotated about the x-axis. So take note that the format of your arc length should be in terms of x, and it should be rotated about the y-axis for you to be able to use this formula. So if it's the other way around, so you're going to solve it using this equation as well. So notice that it's 2 pi x. So again, the moment arm is perpendicular to the axis of rotation. So if we're going to rotate about the x-axis, so notice that this will be, the radius will be equal to y. If we're going to rotate about the y-axis, so notice that the radius or the moment arm will be equal to x. Okay. So let's try to solve this equation. So you're going to be determining the surface area of the solid obtained by rotating y equals square root of 9 minus x squared, and then minus 2. Sorry, so it's not minus 2. So from negative 2 going to positive 2, then it's rotated about the x-axis. So again, by formula, if we're going to use the formula, so that will be 2 pi. So from x1 to x2. So again, since we are rotating in the in the x-axis, so the radius will be the y. That will be perpendicular to the axis of rotation. So square root of 1 plus dy over dx squared dx. So that will be our equation. So also take note that the equation on the left portion, in the graph, that will be the surface area generated. So again, time and time again, so I'm going to repeat it. You're going to be generating your own graph, and then you're going to provide solutions or evidences for your graph. All right, so next step is you're going to determine the different parts of the formula, such as your y variable, and then the other one is your dy over dx. Okay, so of course the radius going towards the line, so the y parameter, so let's try to change color again for us to appreciate the. So first is we need to determine this one, the y variable. So again, the radius of your semicircle, of your circle, so since it's touching this line, so that will be your y, or that will be the radius. So the radius is touching this particular line, which is equal to square root of 9 minus x squared. Okay, so we already solved with the y parameter. So let's try to determine now the dy over dx. So dy over dx, so we're going to be differentiating square root of 9 minus x squared. So in terms of exponential form, 9 minus x squared to the power of 1/2. So getting the derivative is we're going to have 1/2 and then times 9 minus x squared to the power of negative 1/2. Then getting the derivative inside the equation, that 9 minus x squared will give you negative 2x. Sakto, di ba? And then rearranging the formula. So this one is we cancel out 2, we cancel out 2 here. So what's left in the equation is x all over, so negative x all over the square root of 9 minus x squared. So this will be our dy over dx. So getting the square of dy over dx as per formula. So this will be x all over the square root of 9 minus x squared squared. So negative 1 squared will be equal to positive 1. X squared is x squared. And then the radical expression in the denominator will be eliminated. So this is 9 minus x squared. So this is equal to dy over dx squared. So plugging it in the equation, so let's go back to the red color. So you're going to have 2 pi from negative 2 to 2, and then y is 9 minus x squared, and then times 1 plus x squared over 9 minus x squared dx. So again, if you want to deal with a difficult equation in your calculator, so try doing so. So probably the calculator will have a hard time, or basin dili pa niya ma-solve ang equation because it's too complicated. So what we need to do is we're going to help our our equation. Okay, so let's try to evaluate this one first. So multiplying fractions, so this becomes 2 pi from negative 2 to 2 square root of 9 minus x squared, and then this becomes so 9 minus x squared plus x squared all over 9 minus x squared. Alright, so minus x squared in the numerator and plus x squared in the numerator will be cancelled out. So what is left in the equation is you're going to have 2 pi negative 2 to 2 square root of 9 minus x squared. Then you're going to have 9 all over 9 minus x squared. So take note that you can try to separate the square roots, numerator and denominator. So you may do this in this fashion. So negative 2 to 2 square root of 9 minus x squared times square root of 9 all over square root of 9 minus x squared. So this will be dx, dx, and then dx. So notice that you can now cancel out 9 minus x squared, and you get the square root of 9, which is 3. So what's left in the equation is you're going to have 2 pi from negative 2 to 2, 3 dx. Or, to make it even more simpler, 6 pi from negative 2 to 2 dx. So it's better if you're going to plug this one in the calculator rather than this one. So basin makuhaan mo oras sa inyong pag-solve sa mga problems. Alright, so the answer will be equal to 24 pi. So instead of L, this should be in terms of S na day. This will be S now because we are now solving for the surface area. So S is equal to 24 pi. So square units. Okay, so questions or clarification? Hello, another question. Okay, so no questions. So let's try to proceed. Okay, so let's try to determine the surface area by rotating y equals cube root of x from 1 to 2 in the y direction, and it should be rotated about the y axis. So again, as per formula for the y axis, so the formula is now shifted. So this will be, as the S, it should be S. I'm sorry. So if this is the line here, so if we try to rotate about the y-axis, so the volume, the surface area generated is more likely like a funnel. All right, so it's more likely a funnel. So surface area is equal to 2 pi. So again, since we're in terms of the direction of we're rotating about the y-axis, so the radius should be perpendicular to the axis of rotation. So that will be x. So from y1 to y2, square root of 1 plus. So this will be, sorry. So dx over dy squared, and then dy. Alright, so we're going to now try to determine the different parts of the equation. So starting off with the x variable. So again, since our given equation is in terms of y, so we're going to convert this one in terms of x. So y equals cube root of x. So getting the cube of both sides, so this becomes y cube is equal to x. So x is equal to y cube. So this one is already checked. So next is we're going to get the derivative of this equation. So dx over dy. So this becomes 3y squared. And then getting the square of this one is you're going to have 9y to the power of 4. So this one is your equation here. So for the limits of integration, so you have 1 going to 2. So simple as that one. So the equation is now 2 pi from 1 to 2, then times the x parameter, that is y cubed, then multiplied by the square root of 1 plus dx over dy squared. That will be 9y to the power of 4 dy. So again, you can try using your calculator here, but again, if the calculator cannot solve your equations right away, or probably ang ibutang sa calculator is math error or some other errors in the, or let's say ang ingon sa calculator kay can't solve. So there are instances nga maingon ang calculator nga can't solve kay naglisod na pud siya, or error na math error. So if you encounter these problems in your calculator later on, so what you need to do here is you really need to simplify first your equations before trying to plug the equation in the calculator. So for example, if this one is complicated, so you can use u sub here, by u sub. So let u is equal to 1 plus 9 to the power of 4, and then du is equal to 36y cubed dy. So I can do that one. Then I'm going to have du all over 36, and then equals y cubed dy. So y cubed dy is found in the equation. Then I'm going to have 2 pi integral from 1 to 2, and then that will be square root of u, and then du over 36. Then I'm going to integrate first before applying the limits of integration. So mga techniques. So you still need the topics or the techniques of integration in simplifying your complicated equations. All right, so the answer is this one. So take note that muna siya ang process of simplifying the equations to help your calculator. So the surface area is 199.48 square units. All right, so this will be your problem set. So only a few items. So 4 for arc length, and then 5 for surface area. I'm just going to post this one in the canvas. So I know that I'm giving you too much problem sets, but muna siya. Problem set wrong ipangayo. There are no other exams. So puro ra problem sets for the 20%. Okay, so questions or clarifications regarding the topic?